Okay, so this is just the second tape. It's the 16th of August, 2008. This is Rob Campbell talking to Harry Orville. Tape 2 of 2. Just a couple more questions. So you were just talking about, so basically, to boil it way down, there's been a curve of popularity, both public popularity for weather modification, and I'm guessing funding agency popularity. You know how these curves go. You've been on both sides of these curves, not necessarily affecting your funding, but your career has spanned.
It actually affected my funding.
It did affect your funding.
Quite a bit, right.
You said you retired in 2000.
Yeah.
So even by the 80s or 90s, it was noticeably tougher to get funding for weather mod research?
Yes. Although there were ups and downs in there. So, but certainly the peak was back in the probably the late 70s, early 80s, and it had gone down. But you, as a scientist, you concentrate more on the cloud physics aspects instead of the weather modification aspects. You concentrate more on the basic aspects of the physics of hail formation or the physics of rain formation. And if you learn more about it, it'll help you in weather modification eventually. So
sure.
There might be a resurgence one of these days.
Yeah, and there's no shortage of topics around.
That's exactly
But you do a proposal more this way, and you tweak it this way. But from what you were saying a minute ago, it sounded to me as if you're saying this isn't necessarily just from science. In other words, you're saying the science supports a lot of operational things that should go into practice. And just when you were talking about the skeptics and the optimists, it sounds so much like the global warming debates of today.
True.
National Academy of Sciences, is the glass half empty, is the glass half full?
That's right. There's a lot of similarities. Global warming, there are things you can do that you should be doing. Whether or not it's true, it's just a good way of living your life and developing your countries and all. So there are very many similarities between the history of global warming and the history of weather modification, right?
And just as a historian, it seems to me as if part of what makes weather modification as a topic of history so fascinating is that it has this, I can't think of another topic like it really. People assume that weather modification is gone, and yet you hear about all kinds of programs, and possibly more programs than ever. But it seems, I don't know if it's anti-environmentalist, or if it seems sort of modernist, or what exactly that is.
I don't know. It's there. It's being done in the western states. Actually, the state of Wyoming in the past 2 years has started a rather major program to try to develop a scientific basis more. So.
And it's just funny how people talk about these as exceptions, but if you put all these exceptions together, that's a lot of weather mod going on. But it's not dismissed and it's not low status, but it's just it doesn't fit what people thought they had learned.
Right.
Well, here's a more practical question. How much of the T28, to your knowledge, the T28 programs, how many of them were seeding programs? How often was the T28 flying through seeded thunderclouds?
Not very many. Most of their work has been the basic science of the severe storms. So we did some work in North Dakota with the T28, where we tried to they put out trace gases, sulfur hexafluoride or something, and with the T28 had a sniffer on it, it would go in and find out where it had gone, and they'd correlate this with if you'd put seeding material in at the same time. But that's really the minority of the work that the T28 has done. The T28 has been on some very good basic cloud physics projects, where they got into severe storms and measured the water contents and the updrafts and downdrafts. Fascinating data that we got from it, but the clouds at the time were not being seeded. Not very many of the Henry clouds do, I think. Did the clouds get measured? The ones that have been seeded. So, but now, again, Paul Smith is the expert.
Sure.
He and Dennis Mussel are the experts in that.
Did you have much to do with the T28 going to Switzerland? You didn't go to Switzerland for that.
That's another. We were actually, I was on my sabbatical in Switzerland, working with the WMO. And the T28 pilot flew into Spain and flew up to, well, he stopped in Geneva and we put him up overnight. So we had our T28 pilot there, and then he went on up to Lucerne or Zurich, wherever they flew out of, you know. So I was there for the summer that they did their work.
But you just happened to be there because Harry Orville is a jet setter.
Harry Orville was the leader of the PEP project at the time, the scientific leader of the PEP project.
So you didn't facilitate the trip to
No.
Switzerland or anything like that?
No. That was a lot of bureaucracy and Paul Smith and the Navy and other things.
And it didn't come out of all these European programs that you were involved in?
No.
Not really?
No. But it was a really good study of some of the convective clouds in Switzerland, and it had to do with that Russian big drop zone theory that was, you know, that we got data that didn't really support that, I don't believe.
As I understand, the Swiss were working in some way with the Russians.
Yeah.
They're testing their theories or sharing...
Bruno Federer was their scientific advisor, and he was a Swiss scientist who we were good friends.
Mhm.
He died, in fact, while I was over there.
Mhm.
So.
No, and I apologize for this question because I'm sure you've been asked this question 36,000 times, but I can't sit and talk to Harry Orville about all these things. The Rapid City flood. People, because when I tell people about what I'm studying, they say, yeah, weren't they seeding the night before the Rapid City flood? And I'm not asking you as if you were responsible or anything.
They were seeding the day of the flood.
The day, right, that's right, the day of the flood. The flood was that night, that's right. The rainstorm was that night. And now I'm not asking you because you're running the program, because you weren't, but as a scientist, is it clear to you what role cloud seeding played in the flood?
Yes.
And what role was that?
I don't think it had any role at all in the flood. This was during one of our summer projects. We were doing three-way testing. We were seeding with salt, seeding with silver iodide, or not seeding on a random basis. And I was actually, I'd left on that, I'd had the briefing on Friday, I think it was, and I'd gone to NCAR to work on the computer, do some work with our cloud models. And I'd been at the briefing that morning. And at the briefing, they always make a decision whether to seed silver iodide, seed salt, or not seed. And I left before the decision. I didn't know what the decision was. When I heard that the flood had occurred, I thought to myself, wow, if we were silver iodide seeding, I think I'll probably leave the field. Because I knew that silver iodide had a way of turning supercooled liquid to ice and releasing latent heat, stimulating the cloud growth. And I said to myself, if we were silver iodide seeding, I may get out of the field. I learned, of course, that we were using seeding with salt, hygroscopic seeding. And I was pretty well convinced that salt doesn't change the dynamics of the cloud nearly as much as silver iodide, so I didn't think there was a chance of it. In later days, we simulated those clouds. We tried to put in an efficient rain process and all, and it didn't affect things significantly at all. So we have modeling results of huge clouds forming over the Black Hills, producing 3 inches of rain every hour or so. And those storms did produce 3 inches for 4 hours, 12 inches, 14 inches over the rain. So we were in the right ballpark for the amount of rain we were producing from our clouds. But the salt seeding, anything that salt seeding would do, had almost negligible effect on those very efficient clouds. They didn't need any help from salt to be producers, rain producers.
Just to clarify, did you just say that you did modeling with data from that very day?
Yes.
The actual flood clouds, as it were?
We used the sounding from those days.
Because you have the data, you had the radar data and the
Right.
sound,
Right.
the aerial data and all that. And so you convinced yourself,
Yeah, we presented a paper on it at a cloud physics meeting a couple of years after the flood, gave our results.
and just to be clear again, you thought, I'll leave the field because you would want to leave the field or because you would
Yeah,
catch it?
I was worried that what we had done, if it had been silver iodide seeding, that we would have participated, would have had something to do with those flood clouds.
Mhm.
So I was very concerned because all the talk those days was explosive growth of clouds from silver iodide seeding.
Now, in the aftermath of that flood, you working at IAS, did you folks feel a lot of political heat? Were you hearing about this?
As a scientist, we knew that we were going to be criticized. We had some scientists criticize us and say that we didn't cause 239 deaths, we only caused 15 deaths or something like that, from the precursor moisture or something like that. But they were crackpots in my opinion. And we were sued, not us individually, but the organization and all. It never held up. The court case was thrown out eventually.
You did not feel uncomfortable in Rapid City?
No.
People didn't ask you at the grocery store?
No, they didn't look at us and blame us for
Nobody
anything.
called your house and
No.
started yelling at you or anything like that?
Dr. Slorsner tried to answer things pretty directly and very quickly. We had a committee here to look at the conditions. And so we were concerned. We were definitely concerned. We had a national meeting in cloud physics here about 2 weeks after the flood, held at the Alex Johnson.
Here?
Yes. So questions.
By
came up.
coincidence?
By coincidence.
Yeah.
It had been planned a year
Sure.
before, 9 months before. So we had a lot of scientists here, cloud physics scientists, and we had presented the information. Probably was pretty good that it was hygroscopic seeding that was being used, because hygroscopic seeding is not known to dynamically influence the clouds.
Does anybody do that kind of seeding today?
Oh, yes.
They do?
Hygroscopic seeding, in fact, looks like it might work very effectively for hail suppression. It makes the rain process more efficient, speeds it up.
But it didn't lead to more rain that day?
No, because those clouds were so efficient, they didn't need any help.
Oh, I see.
It was extremely efficient. And 4 years later, in Big Thompson, you have almost exactly the same synoptic weather condition. Almost exactly the same weather condition. 4 years later, the flood in Big Thompson.
Wait, that's Colorado?
Not in Colorado,
Mhm.
not an ounce of cloud seeding was used.
Sure.
And the results were very, very similar between Rapid City and Big Thompson.
And weren't you seeding hours earlier? This is a very crude question.
Up until about 6 o'clock.
Till about 6 o'clock.
Started about 2 in the afternoon.
And the rain started?
And it started up around Sturgis and then went down Hermosa and down there.
The seeding?
Cloud seeding, right.
And then the rain started?
The rain started probably 6 through 9 o'clock. or
Oh,
something
okay.
like
So it's not that there was a big time gap?
No, not a huge time gap from our laser seeding.
And it wasn't the fact?
But the weather situation is one in which the clouds were eventually forced up over the Black Hills. And when they get forced up over the Black Hills, it released a lot of energy. And that's when the clouds grew to 40,000 feet or so.
Oh, I see.
We were working on clouds that were going to about 30,000 feet, 30,000 feet out over the plains. When they got pushed up over the hills and they released instability in the atmosphere, and when they were super clouds, and they didn't move. They were stationary for quite a while.
So the perception, people said, well, it wasn't their fault because those clouds would have blown east by then. That's not true at all. Okay. In fact, I was going to ask you, rain seeding versus hail seeding.
Mm-hmm.
You would seed in different ways using different materials depending on whether your goal was...
You might use the same material. Silver iodide can work for rain enhancement. it could work for creating more hail embryos and helping to decrease hail. So you could use silver iodide for rain enhancement and hail suppression in certain situations. But the clouds are going to be different characteristic for rain or for hail.
Okay. In fact, the very same seeding that makes it rain could very well make the hail less likely. It's the same process?
Yes.
And why is it that the seeding, you're giving nuclei to raindrops? Is that true to say?
You're creating rain, and rain is the embryo for hail. So the more embryos you can form, it's a competition. There's a conservation of water in the clouds, so the more embryos you can form, the smaller the hail would be, or it would be so small that it would melt into rain. So it's a competition. It's a beneficial competition. You don't always have to have beneficial competition, but if you do have beneficial competition, that means you're producing so many embryos for the hail that the hail stays small and melts.
Oh, I see.
So producing the rain process can also affect the hail process.
In fact, so the seeding can in fact create hail, very small hail,
That's right.
and harmless hail.
That's right.
I understand.
And
Because
one reason you maybe have more hail in this area than you do in Miami, Florida is Miami, Florida has very low base clouds, has a lot of rain in it. Those raindrops are carried back up into the strong clouds. Many, many hail embryos, they come out and melt in the rain and melt before they're hail.
I see.
Whereas we have high base clouds and the hail comes out of the base and gets to the ground.
Because for rain to form or hail to form, they both need the same
That's right.
nuclei.
That's right.
Or embryos.
That's right.
I see. So it is a tricky business.
It is. Yep.
You can actually prevent damaging hail by creating hail, by creating lots of little hail.
That's right. Exactly right.
That is sneaky stuff.
Yeah.
I have just one more question, I promise.
Yep.
And it's a mundane question. All these data that came out, either from the T28 or the radars or whatever, let's say 1960s, 1970s, did you immediately share it with the scientific community? The data, I mean, the raw data.
Oh, yeah. We had no reason to hide our data. I mean, in science, you publish. You're in the business of publishing. So we would publish our papers and our data. We published our information on our cloud seeding and presented it at scientific meetings. We were active. We were a very active group.
Right, but just on a totally mundane level, you know, the paper might take at least 6 months for you to get published, right?
Oh, yeah.
Did
6
other
months
people
to
have
a
a
year.
crack at that data before you were done with it, or did you say, no, we get it first, or that was, is that an issue?
I'm not sure anybody ever asked us about
Oh.
it. But I think Arnett Dennis or Jim Miller would have not hesitated to say, come in and look over the data.
There was no proprietary sense of the data saying, well, you can have it once we're done with it? That,
I don't recall that.
that was not an issue? Okay.
No.
Because these days, of course, what you do, you put it on the internet.
Oh, yeah.
I don't even know how you shared data back then. I don't know what you did.
You have to come here and
You copied
do the
tapes or you
paperwork, yeah.
sent them paper or
That's
something.
right. That's right. And we had a lot of tape or cards, a lot of data on cards at one time.
Yeah, Dick Farley on his door still has Dick Farley punched out in a computer card.
Yeah.
I love that. I think I took a picture of it as a historian.
Dick is an outstanding scientist. He's probably the leading numerical modeler around for lightning and atmospheric electricity, and John Helsden. John Helsden's a theoretician, and Dick's the one that makes the models work. And Dick's a genius with codes, numerical codes.
Well, when people talk about the IAS, one of the things they definitely talk about still today is modeling. I say that's what they're known for, so I think you can feel good about that. They have nice things to say about you, Harry.
Okay.
And I thank you very much for your time today. I really do appreciate it. It's been very interesting.
Okay.
Thanks a lot.
You're very welcome.